Today we are talking about sequences. So we need to start out, there's quite a bit of vocabulary with this, so let's talk about what all these words here mean. So a sequence, which I'm sure you're familiar with, is an ordered list of numbers. Each number in the list is a term. An arithmetic, looks like arithmetic, an arithmetic sequence is a sequence in which the difference between any two consecutive terms is the same. I'm going to tell you what all this means in just a second. The place the term is in the sequence is called the position, which is represented by the variable n. N is always going to be the position. The difference between the terms is the common difference. Okay, so a sequence is an ordered list of numbers. So here we have an example, 3, 5, 7, 9, 11. That is an ordered list of numbers. Each number in the list is a term. So 3 is a term, 5 is a term, 7 is a term, 9 is a term, 11 is a term. So every number in the sequence is a term. This is an arithmetic sequence because it has the same difference between each term in the sequence. So we're adding 2 plus 2 plus 2 plus 2 plus 2 every time. So this is arithmetic because it is, we're adding, and it could also be subtracting. If this sequence went backwards, if it went like this, then our common difference would be minus 2 every time. And that is still an arithmetic sequence. So we can add or subtract. Now, the place in the sequence where that term is located is the position. So, for example, this is the first position. So that's position number 1, term number 1. This is the second, the third, the fourth, the fifth. Okay, and we talked about the fact that the common difference could be a plus 2 minus 2, could be plus 3, plus 5. Okay, so that's the basic vocabulary of what we're doing today. Term, position, common difference. We'll be using these terms quite a bit. So here is the sequence that we just looked at. And here we have n. N is 1, 2, 3. Those are the positions. And I'm going to go ahead and put position here. It's really important that you understand what the position is. And then the terms. So this is our actual sequence, 3, 5, 7, 9, 11, 13. So when we are writing a rule, so what we're doing today is we're actually going to write a rule so that we can find any term in the sequence. So if I wanted to know what the 1,000th term was, or the 10th term, instead of adding up to 1,000, I would find a rule so that I could find any position. So the way we're going to do that, the first thing we're going to do is find the common difference. So the first thing you're going to do is find the common difference. So here I'm adding 2 every time. Going to add 2 every single time. So the second thing I'm going to do is I'm going to multiply the common difference by n. So my common difference was 2, so I'm going to say 2n. And then the third thing I'm going to do is I'm going to check my rule and then make adjustments as necessary. So I'm going to check my rule. Now, this is how I'm going to check my rule. What did N stand for? N stands for the position in the sequence. So think of it as input-output. I'm going to input my N, my position, and see if once I use that rule, if my output matches. So let me show you what I mean by that. If I do 2 times the first position, 2 times 1, I would get 2. If I go back and check the term in that position, it doesn't match. So what would I have to do to the 2 to make it a 3? I would add 1, and that would then be the correct term. So let's test this. If I do 2 times the second position plus 1, that's 2 times 2 is 4, plus 1 is 5. And this matches the second position. So my rule is going to be 2n plus 1. Now I want to check it and make sure that this actually matches my sequence. So my sequence was 3, 5, 7, 9, 11, 13. So if I go in and I substitute the position number for n and add 1, my output should match my sequence. So 2 times position number 1 is 2, and 2 plus 1 is 3. That matches. 2 times 2 is 4, plus 1 is 5. 2 times 3 plus 1 is 7. 2 times 4 is 8, plus 1 is 9. And so this looks like it's the correct rule because when I input any of the position numbers for n and work the rule, I get the same sequence. So let's try this on a different sequence here. So we're going to write and solve an expression to find the nth term of each sequence. Again, we're finding the rule for this sequence. So the first thing that we were supposed to do is find the common difference. So what's happening each time in this sequence? We're adding 5. 4 plus 5 is 9. 9 plus 5 is 14. 14 plus 5 is 19. So the first thing we did was find the common difference, 5. The second thing we have to do is multiply that common difference by n, 5n. And then the third thing was to check our rule and see if it matches the sequence. So again, this is position number 1, position number 2, position number 3, position number 4. I'm going to input, remember position is the n, I'm going to try these out. 5 times 1 is 5. That does not match my sequence. So what would I have to do to that 5 to get to 4? Take away 1. That would be 4. So my rule should be 5n minus 1. But let's test it. 5 times 2 is 10, minus 1 is 9. That matches. 5 times position number 3 minus 1. 5 times 3 is 15, minus 1 is 14. And 5 times 4 minus 1, so 5 times 4 is 20, minus 1 is 19. So our rule, our expression, is 5n minus 1. I could use this expression to find the 1,000th term in this sequence if I wanted to. Okay, let's look at number 2. We have 6, 10, 14, 18. First thing we're going to do, find the common difference. The common difference here, is 4, adding 4. So every time I'm adding 4. Second thing we do is we multiply the common difference times n. Now if I check my rule, 4 times 1, position number 1, should be 6. It's not 6. So what do I have to do to 4 to get to 6? I add 2. And that would be 6. So my rule should be 4n plus 2. So let's test it. 4 times position number 2 plus 2. 4 times 2 is 8, plus 2 is 10. 4 times position number 3 plus 2. 4 times 3 is 12, plus 2 is 14. 4 times position number 4 plus 2. 16 plus 2 is 18. So that matches my sequence. So 4n plus 2 is my rule or the expression. I would like for you to try number 3 on your own. Remember, we're finding the common difference first. We're multiplying the common difference by n, and then we're testing the position. Position number 1, what is the output? Position number 2, what is the output? We will check that in class tomorrow. Now, you may also see a question like this where it's in a table format, and we want to know what the value of the 20th term is. Now, we don't want to do this sequence all the way to the 20th position, so we want to write a rule. So again, we're going to look at the common difference. What's happening from 3 to 6? We're adding 3. 6 to 9, adding 3. 9 to 12, adding 3. Again, it's not always going to add. Sometimes we could subtract. The common difference could be a subtraction, which would be a negative. Now I'm going to multiply by n and then test it. 3 times position number 1 is 3. That matches. 3 times position number 2 is 6. That matches. 3 times position number 3 is 9. That matches. So 3n is my rule. But now I need to find the 20th term. So 3 times 20 is 60. So the 20th term in this sequence would be 60. Okay, number 5, I would like for you to try that one on your own. You're trying to find the 30th term in the sequence. And tomorrow in class, we will look at more types of sequences that maybe we don't write the rule for, but that we have to determine which rule matches the sequence.